Baskerville Radio.
Hello. This recording accompanies the PowerPoint presentation called Changing State. You can pause this recording anytime you like. We'll begin on slide 2 of the presentation. Understanding changes of state is important when working with materials. Glass blowing, casting metal, and cooking are all activities in which changes of state are used to create a finished product. Slide 3. A material changes its state because energy is either added or taken away from its thermal store, how much heat it has. Adding energy to a solid makes its particles vibrate further and faster until the bonds between particles weaken enough for the particles to move past each other. The solid has now melted into a liquid. Adding energy to a liquid makes its particle move around further and faster until they have enough energy to break their bonds and become free to move anywhere. When this happens, the liquid has become a gas. A substance can become a gas in 3 ways: evaporation, boiling, and sublimation. Slide 4. Figure 2 shows changes of state. So we can see a solid melting to become a liquid, and then a liquid boiling or evaporating to become a gas. Sublimation is when a solid changes straight into a gas. We'll talk more about this later. At the bottom, we can see that condensation is when a gas turns into a liquid, and then the liquid freezes to become a solid. Slide 5. Evaporation. Only the particles at the surface of the liquid are involved. They are the only particles with enough energy to break free. The liquid doesn't bubble. Evaporation happens at all temperatures, so not just at the liquid's boiling point. Boiling. All the particles in the liquid are involved. They all have enough energy to break free. The liquid bubbles. Boiling happens at a fixed temperature called the boiling point. Sublimation. Some substances have a melting point and a boiling point so close together that when they're heated, they do not melt but turn straight into a gas. This is called sublimation, and iodine is an example of such a substance. Melting. Melting, like boiling, happens at a fixed temperature for a given liquid. These temperatures are different for different liquids. In the table on slide 5, you can see the melting point and boiling point for pure water and mercury. You'll need this information to answer the questions at the end. So, pure water has a melting point of 0 degrees Celsius. That means that below 0 degrees, water freezes, and we call it ice, and above 0 degrees, it melts into liquid water. If we heat water up to 100 degrees Celsius, it boils and turns into what we call steam. Slide 6. Removing energy. Change of state is a physical change, which means it can be reversed. Cooling a gas takes energy from its particles so they slow down and move closer together. The gas condenses into a liquid. Cooling a liquid takes energy from its particles so they can't move around and can only vibrate. The liquid freezes into a solid. When substances change state, particles do not change size or mass. They just arrange themselves differently. If you melt a kilogram of solid iron, you will get a kilogram of liquid iron. Slide 7. Questions. Explain the difference between the arrows on the liquid particles and those on the gas particles in Figure 2. Question 2. Which arrangement has the most energy, solid or gas? Question 3. Why is mercury a good choice of liquid to use in a thermometer? What problems could there be if water was used instead? Question 4. Compare the effect of heating a liquid and a gas. Question 5. Puddles are an example of water evaporating. Describe this process and explain how it differs from boiling. Explain why we don't see it happening. Thank you for listening. Bye for now.
Baskerville Radio.